Today we'll be solving the chemistry P4, May-June 2020. You are already aware of the instructions, so we'll be just proceeding to the questions. The question number one, this question is about elements X, Y, and Z. An atom of element X is represented as X1634. Name of the type of particles found in the nucleus of the atom. So in the nucleus of the atom, I already filled that is the protons and neutrons. Question 1A, part 2. What is the term for the total number of particles in the nucleus of an atom? So you already know that the term will be the nucleon number for the particles in the nucleus. And what is the total number of particles in the nucleus of an atom of X1634? So we'll be talking about only the nucleus. So the number of particles in the nucleus is protons plus neutrons, which is 34. And then what is the electronic structure of the ion X minus 2? So having a negative 2 charge means it has accepted the 2 electrons in the neutral entity, and the number of protons is equal to the number of electrons. So here the number of electrons was 16, and with negative 2 charge they have become 18. So while writing the electronic structure, we'll be considering this negative 2 charge as well, and so it will be 2, 8, and 8. Suggest the formula of the compound found between aluminium and X. So X, as per the electronic configuration, belongs to group 6, and aluminium belonging to group 3. The formula, if we talk about the formula, it can be Al2 and X3. How it can be, aluminium will be losing 3 electrons, but one atom of X can accept only 2 electrons. So we'll be satisfying the valencies and the charges, and they will be satisfied at the number 6. So 2 units of aluminium will be losing 6 electrons, and 3 units of atom X will be accepting the 6 electron, 2 electrons by each atom. What term is used to describe atoms of the same element with the different numbers of particles in the nucleus? So I hope people already know isotope. Isotopes are the atoms of the same element having the same atomic number but different atomic mass, or the different nucleon number, or we can say different number of neutrons. Identify the atom against which the relative masses of all other atoms are compared. So we already know that is carbon 12. We can also write it as C12. It's up to you the way you write, but it will be correct. What is the name of the amount of any substance that contains 6.02 multiplied 10 to the power raised of 23 particles? So that is equal to 1 mole, or we can also write on the mole. Either the way it is correct. The constant 6.02 10 raised power 23 has a name. What is the name of the constant? So you might know it as Avogadro's constant, or we say Avogadro's number. Part of the definition of relative atomic mass is the average mass of naturally occurring atoms of an element. Okay, so some relative atomic masses are not whole numbers. Element Y has only 2 different types of atoms, Y69 and Y71. The ratio of the atoms present in the element Y is shown, that is 3:2. So calculate the relative atomic mass of the element to 1 decimal place. So how we can do? we'll be doing multiplying the atomic masses with their ratio, that is for Y69 we'll be doing like this: 69 multiplied by 3 plus 71 multiplied by 2. That gives us the answer of about 369 and then 71 plus 2. That is about 349. And then we'll be doing for the average, what we'll be doing will be dividing 349 with the total sum of the ratio, that is 3:2, which becomes 5, and it is equal to 5, 6 are 30, 4, 49, 5, 8 are 40, 5, 9 are 45, and then 45, 8 are 40. 69.8. So the answer relative atomic mass is, it says Y to one decimal place value, that is 69.8. And identify the Y, so we'll be straight running to the periodic table and we'll be checking out the atomic masses of the elements here, being 30, 65, helium, and 31, 70. So 70 is the nearest to the 69.8. So our element that we are having here is gallium, G-A-L-I-U-M. Okay, so 1 mark is for the first step, that we do the first steps calculation. Second mark is for providing the relative atomic mass, and third mark is for providing the limit. Element Z is in period 3 and group 5, element Z. So again, straight run to the periodic table, period 3 and group 5. So there you go, period 1, 2, 3, and group 5. So it is phosphorus 1531. So identifying the element Z, that is phosphorus. Explain in terms of electron transfer why Z behaves chemically as non-metal. As people already know, the metallic character is related to the number of electrons that can be donated by an element. So the Z belonging to group 5, it doesn't lose the electron, it will be forming a -3 ion by accepting 3 electrons. We'll be saying it will form negative ion by gaining 3 electrons to complete outermost shell, which is the property of non-metals. Okay, so gaining the electron is the property of non-metals, or we can just say, we can, in simple word, we can say it will be forming a negative ion of -3 charge. 1 mark will be for the formation of negative ion, and how much negative ion it will be, how much electron it will be accepting, that is how many electrons. So 1 mark for the mentioning the charge, and second mark is for the providing the number of electrons that can be accepted by element. See. Moving to the question number 2, magnesium is a metal. Name and describe the bonding in magnesium. So it's a metal, so the bonding is the metallic bonding. And if we talk about the description of bonding, so what we'll be saying that the positive metal ions are surrounded by the delocalized sea of electrons, and the strong, sorry about it, here, and the strong forces of attraction between them keeps the particles together. So here from the 4 marks, first mark is for the metallic bonding, second mark is for sea of electrons, third mark is for positive metal ions, and fourth mark is for strong force of attraction between these particles. So magnesium oxide MgO is found when magnesium burns with oxygen. Complete the dot and cross structure dot and cross diagram to show the electrons arrangement of the ions in the magnesium oxide. The inner shells have been drawn, give the charges on the ions too. So here these are the only first shell of both of the atoms is given. So we need to draw the rest of the structure, as well as we need to provide the charges. So magnesium oxide, as you could already know, magnesium belongs to group 2, so it will be losing 2 electrons, and oxygen belonging to group 6, it will be gaining 2 electrons. Charges, and then we need to draw the outermost shell. There is the shell for magnesium, and then a shell for oxygen. So here we need to take care of the things like magnesium belongs to third period, so it usually has 3 shells, but in the state of the positive 2, in the ionic state, the outermost shell will be dissolved, so it will be having only 2 shells, and both of them will be complete. The first shell is the 2 electrons, and the second shell is the 8 electrons. So you guys can see here the first shells are given in the dot form, so we'll be drawing the dots here. 1, and second shell has 8 electrons as total. 4, 6, and 8. But for the oxygen, the first shell is given in the cross form, which means that the second shell of the oxygen has 6 electrons, so there will be 6 crosses. Here, and then the 2 electrons the oxygen has gained from the magnesium atom, these two will be dots here, they will not be the crosses, as these two are not their own electrons, not the electrons of the oxygen, but it has gained the electrons uh, from the magnesium atom. So we'll be trying the dots here. So I'll be just providing the stars to highlight it here. Okay. I hope you people understand the whole part. So from 3 marks, 1 mark is for the drawing the shells correctly. Second mark is for providing the correct representation of the dot and cross structure, and third mark is for providing the charges. Write the chemical equation for the reaction that occurs when magnesium burns with oxygen. So here Mg plus O2 changes to form MgO. But if you guys can take a look here, it is not a balanced chemical equation, so we need to balance it by providing the correct number. As oxygen does not exist in an atomic form, it will be existing as in diatomic state, so we need to balance it accordingly. Yes, the formula is MgO, but we need to provide the balanced chemical equation for the 2 marks. Here 1 mark is for providing the correct symbols, and second mark is for the correct balance. Magnesium oxide also forms when magnesium nitrate is heated strongly. This is an exothermic reaction, so we'll write the chemical equation for this. So here it says heated strongly, it doesn't say it is reacting with something else, so it means that magnesium nitrate will be decomposing here. So magnesium nitrate NO3 twice when heated, it gives us, as it says, products are, one of the products is magnesium oxide, so MgO, and plus whenever nitrate is heated, NO2 is also product, and then last product will be the oxygen. Now we need to balance it. If we go for the magnesium nitrate, and it says we need to balance the nitrogen, that is 2 nitrogens here, and if we go for the oxygen, the 3 there 6. So here we can see 2 oxygens here, 2 oxygens here, and 1 oxygen here. That makes a total of 5. So we need to convert this number to an even number. That will be done by writing 2 here. This 2 makes the nitrogen 4. 2 from here and 2, 4. Now these 2 make the magnesium atoms as 2 as And now if we talk about the balancing part, if we just calculate the number of particles here, so we can just balance the liquid part to magnesium or nitrogen or oxygen. It's up to you. Like if you go for the magnesium, magnesium are balanced here. If you go for the nitrogen, nitrogen are balanced here. If you go for the oxygen, 2, 3 there, 6, 6 12 and 2, there 8, 10 and plus 2. So all the number of particles are balanced here, so the equation is balanced. What type of the reaction is this? As the statement says, heated strongly, so it is thermal decomposition. Thermal decomposition. Name 2 other compounds of magnesium that form magnesium oxide when heated. So it says that we need to provide 2 other compounds. So these are magnesium carbonate and magnesium hydroxide. When these two are heated, they are also thermally decomposed and they give us the magnesium oxide. So question number 3 is sulfur dioxide is used in the manufacture of sulfuric acid. In the first stage of the process, sulfur dioxide is obtained from sulfur-containing ores. Name one of these ores. The ore of sulfur that is used is a zinc blende, which is a combination of zinc and sulfur. It's an inorganic compound. Zinc sulfide is its chemical name. The next stage of the process is the reaction which can reach equilibrium. So here's the reaction and we need to provide the two features. Obviously the reversible reaction, like the reaction can be reversed, and then the rate of forward reaction becomes equal to rate of reverse reaction. Name a catalyst that is used in this stage. The vanadium pentoxide. Vanadium is a transition element, so we'll be writing the oxidation state as this oxide. So why is the catalyst used? Obviously to increase the rate of reaction. So we use catalyst for increasing the rate of reaction. How are the catalyst increases rate of reaction? By lowering the activation energy and by providing the alternate path for the reaction to increase the rate of reaction. Okay, so explain in terms of particles why a high temperature increases the rate of reaction. Increasing the temperature means the particles are moving much faster. So we'll be saying that particles have a higher energy at high temperature, and it means that they are moving faster, so the rate of successive collision is higher. A successive collision means that the reactants will be converting to the products. Successive, okay, here you go. And obviously the more particles, more number of particles will be having the energy higher than the activation energy. Okay, so you guys can provide your own wording, you guys can provide your own statements, but these are the major. In this stage, only a moderate temperature of 450 degrees Celsius is used. What does this suggest about the forward reaction? Using a moderate temperature for such kind of reactions, it means that if we are going to provide the high temperature, the reaction will not proceed smoothly. So, exothermic. Forward reaction exothermic, so we are providing the exothermic reaction. Okay, so we are not providing the higher temperatures. Calculate the percentage by mass of sulfur in sulfur trioxide. So we already know that percentage is 100 multiplied by the mass of sulfur. Sulfur is 32 divided by the mass of sulfur trioxide, that is 16 3 of 38, and then 32, that makes 80. So that if we go for the calculations, it will be providing about 40%. Okay, the C part says concentrated sulfuric acid is a dehydrating agent which can chemically remove water from substances. So both hydrogen copper sulfate crystals and sucrose, a sugar that is C12H22O11, can be completely dehydrated by concentrated sulfuric acid. Name the solid product formed in each case. So hydrated copper sulfate, when the water is removed, it becomes anhydrous copper sulfate. Here we need to mention the oxidation state. And here sucrose, if you can see here 11 oxygens and 12 water hydrogens, which makes the 11 water molecules. So here we'll be having only carbon. So when one propane 1-ol is heated with concentrated sulfuric acid as a catalyst, and unsaturated hydrocarbon of relative molecular mass 42 is formed, and one other product. What is meant by the term unsaturated? So in the organic chemistry, whenever we'll be using the term unsaturated, it means that not all C bonds C are single covalent bonds. It means at least there should be one carbon-carbon double bond to make the structure unsaturated. Okay, write the chemical equation for this reaction. So if we talk about the propane 1-ol, propane is 3 carbons, CH3, H7, OH changes to form C3, H6 plus H2O. Name the unsaturated hydrocarbon form, that is, it is from the propane, so it is propene, alkenes. Okay, so we'll be moving to question number 4. This question is about reactions of bases and acids. Ammonia is a gas at room temperature. What is the test for ammonium gas? Describe the positive results. So that is camp litmus. It will be turned blue. And ammonia is the base, so it will be turning blue. How does the ammonia reacts with water to form NH4 positive ion? So it is a proton acceptor. They're accepting the hydrogen ion, so the base accepts the hydrogen ion. Ammonia is described as a weaker base, just a pH equals ammonia. So any value above 7 to 11. So writing any value till 11, 7 to above 7 to 11, so will be like 7.5 or 8 to 11. Any value you can write, but you will be providing single answer. Like here, I'll be saying, let's just say 10 or 9. So that's a weak base. Describe what is seen when aqueous ammonia is added to copper sulfate. until no further change is seen. So when we start adding the ammonia, the blue precipitates form. Blue precipitate is formed at first, but if we keep on adding the ammonia, it dissolves. And the last part, no further change is seen. So solution remains blue. There will be no further change after dissolving the precipitate, blue precipitate. So the solution will be staying blue. Aqueous sodium hydroxide is a strong alkali that reacts with dilute sulfuric acid exothermically. So what type of reaction is this? Obviously the strong alkali is reacting with the sulfuric acid. So the common acid-base reaction is the neutralization reaction. What will be the products of the acid-base reaction? Salt of the respective metal, Na2SO4 and water, H2O. Okay, so as a student wanted to find the concentration of some dilute sulfuric acid by titration, the student found that 25 cubic centimeter of 0.0400 mole per decimeter cube sodium hydroxide reacted exactly with the 20.0 cubic centimeter of water. Name a suitable indicator to use in this titration. So we can just say methyl orange. Second part is to calculate the concentration of the H2SO4 aqueous in mole per decimeter cube using the following steps. So calculate the number of moles of NaOH in 25 cubic centimeters. So we are provided with the volume here, not the masses. So we'll be using the formula concentration equals to number of moles divided by given volume in decimeter cubes. So here we need to find the number of moles. So what we'll be doing will be switching the position here. So number of moles N will be equal to C multiplied V. But one thing to remember, it will be in decimeter cubes. So given volume should be converted to the decimeter cube. How we can do? We can just convert it to decimeter cube by dividing it with 1000. So it will be 0.025. So here we'll be using what? N is equal to concentration here already given 0.04, 0.04, and then we'll be multiplying it with 0.025. So the answer here will be, let's go for the calculator here, 0.04 multiplied with 0.025 times 0.001. 0.001. Okay, so deduce the number of mole of H2SO4 that reacted with the 25 cubic centimeter of NaOH. So here we are not provided with any of the details for the sodium, for the sulfuric acid. So what we'll be doing, we'll be just going to the balanced chemical equation here. So So here we could say that 2 moles of sodium hydroxide are consuming the 1 mole of sulfuric acid. So which means that if we are going to take 1 mole of sodium hydroxide, sulfuric acid will be half. So what we'll be doing, we'll be taking the half of the number of moles of sodium hydroxide. Okay, so simply what we'll be doing, 0.001 divided by 2, which gives us the answer 0.005. Let's see if this works. So 0.001 divided by 2 gives 0.405. Okay. So calculate the concentration of H2SO4 in moles per decimeter cubes. So we have got the moles, we have the volume here, so we'll be using the concentration, this formula here. C is equal to N over V, but still we need to convert the V, the volume here, into decimeter cube. So what is the volume given here? Exactly the 20 cubic centimeters. So when 20 cubic centimeters are converted to the decimeter cube, will be doing that. C equals to 0.0505 multiplied. When we convert 20 into decimeter cubes, it will be 0.02. So 0.25 multiplied with 0.02 becomes 0.01 moles per decimeter cube. Okay. So calculate the concentration of 0.0400 mole per decimeter cube of sodium hydroxide in grams per decimeter cube. So what we'll be doing is we'll be multiplying the 0.04 with MR of NaOH, which is 40. So the answer will be 0.04 multiplied with 40. It gives us 1.6. Whenever we need to calculate the concentration in grams per decimeter cube instead of moles per decimeter cube, we will multiply it with the MR. Okay, so ethanol is manufactured by 2 different processes. So for each process, the organic reactant, if we are going to take the organic reactant sugar, we'll be using fermentation, and we are using the ethene or any alkene, will be following hydration. Hydration means that we'll be reacting with steam and will be providing us the load. Alcohols can be oxidized to form carboxylic acid. Name a suitable oxidizing agent. Whenever you are asked for a suitable oxidizing agent, potassium permanganate is one of the best oxidizing agent, that is KMNO4 is the oxidizing agent other than any other like chromate or any peroxide or superoxide. So it will be used. It is from the manganese, potassium permanganate. And most of the time when we are reacting with the base, we will be using the acidified potassium permanganate. Okay, so alcohols can be partially oxidized to form aldehydes. Aldehydes are homologous series. Aldehydes and ketones so far are not in your syllabus, but discussing about the apparatus, name the apparatus A. It is the condenser. CONDENSOR, condenser. On the diagram, use one arrow to show where the water enters the apparatus A. So whenever we'll be using the condenser, its inlet will be downward and the outlet will be the upward side. Okay, so here from the condenser, the water enters from here and leaves from here. So if we just draw, so it will be from here. What is the purpose of this part here? It is that the water will be staying for the more time and it will be providing us the effective condensation. Then the table shows some information about the aldehyde. Complete the name. So following this sequence, yes, it is a single carbon, so here it will be methanol, ethanol, propanol, butanol, and butanol will be C4. H8. Oh, deduce the general formula of aldehyde. So following these formulas, we can just say it is CH2O. The structural formula of the ethanol is given here. The C double bond O group in aldehyde is at the end of the carbon chain. What is the name of the reactive part of the organic molecule? So that is the functional group. In all the organic molecules, the functional group attached to the organic molecule determines the reactivity of that molecule. Complete the dot and cross structure diagram for this part here. For oxygen, crosses are given. So what we'll be doing, it is the second shell of oxygen. So we'll be providing the crosses here. And it is, if we just see the structure here, it is C double bond O. So here the two crosses will be here, where oxygen and carbon is showing with the dots. So we'll be providing the dots, two dots for carbon. It's a covalent bond, so we'll be providing the dot in this loop, that is like Venn diagram. So one dot for here, one for here, and here. So presentation of the hydrogen is not given, so we can use any other. Picker one will be for the hydrogens. Okay. And this part is remaining here. As carbon-carbon bonds are single, so it will be only one single bond consists of two electrons, that is one pair of electron, one electron given by the each side. Okay, so propanone belongs to the homologous series called ketones. Ketones have the C double bond O group as aldehyde, but the C double bond O group is not at the end of the carbon chain. Propanone has the same molecular formula as propanol C3H6O. What term is used to describe molecules with different structures but the same molecular formula? That is isomers. The term isomers means the compounds or the species having the same molecular formula. The different structure formula suggests the structure of propanone, show all the atoms and bonds. If we just follow the statement says that it will not be at the terminal. So what we can do, C, C, C. So we'll be adding the oxygen in the middle here. So we can see the all the four bonds of the central carbon are occupied. So we'll be adding the hydrogen to the rest of the carbons. H, H, there you go. So that's all for from the P4, and here's the periodic table, and thank you so much for being here. If there's any confusion or if you think that if you could not understand any of the concepts or any of the points, you can just add it in the comments and let's just see if I could be there to answer your query.